Hello all, welcome to Code Hub. Today let us solve the LeetCode daily challenge. The question is interleaving strings. Given string S1, S2 and S3, find whether S3 is formed by an interleaving of S1 and S2. And interleaving of two strings S and T is a configuration where they are divided into non-empty substrings such that this S and T forms S3 or not. We have to check if I combine S1 and S2. So let us take the example so that you will be more clear. S1 the string is AA B C C. The string S2 is D B B C A. The string S3 is AA D B B C B C A C. So I will consider this string S1 and S2. I have to combine this S1 and S2 to make S3. First we can take this character. First we can take the character A from S1. Next we can take the second character A from S1. Next we can take the character D from S2. Then we can take the character B from S1, or we can take the character B from S2. Either way we can take the character B from S1 itself. Then we can take another character B from S2. Now we will take the character C from S1. This becomes C, and the left out characters are C and BCA from S2. Now next we can take B from the string S2. Now the left out characters are C and CA. Next we can take the character C from we can try to take the character C from string S2. Next we will left out with A from string S2 and C from string S1. Next we can take the character A from S2. Next we can take the character C from S1. So as you can see that when I combine this S1, the characters from S1 and S2 in some rearrangement, some possible order, I have made S3. So this is the question. So how if I can make S3, then I have to return true. Let us try another possibility of taking this. Let us take this CAC. Now we will try to take the character C from S1, from the string S1. Now we have the S1 has completed. Now we have no characters left out in S1. Now we have to take character A from character A to match the string S3. But we don't have character A from string S1. We have a character A from the string S2, but we have to take this C before this A, right? So we have to combine this to make this as S3. We have to take this C, and then only we have to take this A. So since I have taken the character C from S1, I couldn't take the character C from this S2, right? So we have to maintain this relative order of S1 and S2 as well to make this S3. That's what I want to make that point. But from the previous way I shown that we can interleave this S1 and S2 to make S3. So it is possible, so we have to return true. So we can take this example 2 as well. In this there are we can take these two characters from S1, it forms. Then we can take this D, then we can take this B, then we can also take the next two characters B from this S1. Next we have to take A, but we couldn't take A since the characters left out in S2 or CA and the characters left out in S1 or CC. We can see that we have to take the characters A first, and then only we can take other three C. But we couldn't take in though that relative by maintaining that relative order. So it is not possible to interleave these two strings S1 and S2 to make S3. So we have to return false. I hope you understand this problem. So consider we have two strings S1 and S2. We can represent those strings as indexes I and J, right? Even there are three strings S3, so we can represent the index of S3 as K. So what is it signify is that here the length of the character, length of the string s1 plus the length of the string s2, if it is equal only, we can try to make this s3. If it is not equal, then we cannot make this s3 at all, right? So we can check first the condition that whether the size, we can get the size int m is equal to s1 dot size and int n is equal to s2 dot size. I will say int mn, another variable, yeah, size to be s3 dot size. If my m plus n is not equal to my size, then I can return false directly, or else I will try to interleave this string s1 and s2. So already I have shown one case that we have to consider all possible ways. So what if we think about all possible ways itself, we have to go with the recursive approach. So this is our intuition of recursive. If we want to get the all possible ways, we have to go for the recursive approach. So how we can go for the recursive approach and how we can write the recurrence relation for that? We can represent this string s1 and s2 in the index as I and j. What we can signify is that we can write a function, recursive function. I will pass the parameters s1, s2 and s3, and I will pass the index I. This is nothing but I, and the index for s2 is nothing but j, which is also starting from 0. Next the index the s3 is starting from k, which is also 0. What this function is going to return me either true or false. This function is going to return me either true or false. If I can interleave these two strings s1 and s2 to make s3, then I will return true, or else I will return false. So what will be the recurrence relation for this? I can check for each characters. If my s1 of I is equal to my s3 of k, then what is the possible recursive function call that I will make for the next iteration? I will say I can choose this index and I will move to the next index of s1. That's what I will say, right? I will pass s1, I will choose this index and I will move to my next index and I will check whether I can interleave this s1 and s2. So I will, but yeah, the index of s2 is staying the same, j, and s3 I have equal to the character of s3 at kth index. So I should move the index to my next position for k plus 1. So this will be my next recursive call. Say we can say it as option 1. I will say this as option 1. As well as if my s1 of s2 of j is equal to my s3 of k, then what it signifies? Then what it signifies is I have another option, option 2, which is I will move my jth index. I will stay my ith index for next recursive call. I will move my s2. I will move the index of s2 to one position forward, and I will move the position of k also one position forward, and I will check it. So finally what we can say is return either of the options. If I got true, I will return either of the options and I will return true and I will exit. So this will be my recurrence relation for this problem. So we can consider the base case now. What will be my base case? If my string is over, what I have to check is when I can return true. When I can return true is if my I has reached the end of the string, end of the string, and my j have reached my end of the string, and also my k have reached my end of the string size, then I can say I will return true. So this will be my base case. What if I have reached the end of the string, but j has not reached the end of the string? So I will be having another couple of base cases, right? If my high have reached the base case, sorry, if the string s1 is exhausted, if my string s1 is exhausted, listen carefully. Consider the string ABB. Yeah, this is s1, and let us say this is an empty string. S1 is empty string and S2 is AB and S3 is AB. So if my string string S1 is exhausted, as you can see, the S1 is an empty string. Then what I should check? J is less than my n. If J is not exhausted, that is S2, the string S2 is not yet exhausted, then and my K is also not yet exhausted, then what I can say is, if my S2 of J is equal to my S3 of K, then I can go for my next recursive call, which is nothing but I will keep the ith index at the stationary position itself. Then I will move this jth position to my next character. That is, consider the I have the jth position here and I have the kth position here. So I am checking that I is exhausted and j is less than n and k is less than size. Then what I will check is, if my s2 of j is equal to my s3 of k, then what I can say is I will return solve of j plus 1, then s3, then k plus 1. I will move my both k and j. Then I will move this k and I will move this j. Now again I is exhausted. J is s2 of j is b and s3 of k is b. Both are equal. Then I will return solve of j plus 1 k plus 1, and I will be ending up this in this case, and I will return true. What if I have c here and I have a here? Then I would have moved here, moved the k for here, and I have moved the j here. Then you can see that s2 is not equal to s3 of k. Then I have to return false. Right. So if if the characters is not same, only the string s2 and s3 is left out, then I will just return false if the characters are not same. This I have to do for the next string also. What if my j is exhausted? J is exhausted and my I is not yet exhausted. I is less than m and my k is less than size. Then my s1 of I then is equal to my s3 of k. Then I have to move I one position forward. J should be staying at the same position and k should be moving to the next position. So this will be my couple of test cases, couple of base cases here, and this will be my recurrence relation, and I will be returning if I get any of the options true, I will be returning this. So it will be private. This option 1 will be private, so I will be declaring outside the if conditions. So we can just copy this code and we can write in our write it in our code itself. So we will cut itself. We will cut this code, cut this part of code. So hope you understand how I approach this recursive approach. So now we have just done the recursive approach. What will be the time complexity here? Time complexity is it grows exponentially, exponential time complexity. Since I will be taking all the possible ways, I will be going for all the possible ways. It will go for 2 power n. It will grow up to 2 power n, and space complexity will also grow exponentially. 2 power n into m, I will say n into m. It will also grow exponential. So how we can optimize this approach? That we can first write the now first we can write our code there for recursive code, then we will discuss the next approach. Solve, I will pass s1, next 0th index I starting, s2 0th index, s3 0th index. Then I will pass these sizes also, so that I don't want to declare there. I will write a function, namely this is a boolean function going to return either true or false. String ampersand s1, string ampersand s2, I will take it as reference, string ampersand s3. Sorry, here this is int I, int j, int k, int m, int n, int s size. So we will copy and we will paste the cases. So this is our code for recursive approach. We will try to run the code, whether we are getting accepted for the example test cases. Oh, we have not passed the sizes, right? N size, and we will copy this and we will paste here, we will paste here, we will paste here, then a semicolon, then a semicolon. Hope this completes it. So we'll run the code. It got accepted. So for example test cases, we will try to submit also. So we got time limit exceeded. So let us try to optimize it. We have written the recursive approach. Now we will try to memoize it. We will be having some sub problems in between. If we store the sub problems and we can make use of it when we see this again, we can reuse it instead of computing each sub problems. So we will change it to a memoization approach. Let us see what are the changing parameters. The changing parameters is I, then j, and then k. These are the parameters that are going to change. So changing parameters is 3. Changing parameters is 3. So what we have to do, we have to declare a 3-dimensional array. So the array is nothing but the size of length is s1 is 100, s2 is 100. So I will declare a 3-dimensional array here instead of declaring there. dp of 101, 101, then the k varies till 200, so 201. So I will declare then I will declare a memset as well, memset of dp. I will initialize it to -1, size of dp. So we have declared a dp, then we have to cache the solution. How we can cache the solution? dp of I, j, k. We have cached it. Now we have to check whether we are not having the it has -1. If it is not -1, we can directly return the intermediate results. We have cached the solution. We will just run the code now. Why it is slow? Okay, we will try to submit the code now. Before that, we will see what is the time complexity here. So recursive approach, this is the time complexity. So the time complexity for memoization solution is, we have declared 3-dimensional array, so it will be order of m into n into k. K is nothing but k, where k is nothing but m plus n. and the space complexity is also order of m into n into k, and we have also an auxiliary stack space, right? We have an auxiliary plus we have an auxiliary stack space. That auxiliary stack space that occurs due to recursion. We will try to reduce even that auxiliary stack space. Before that, we will submit the code here. So this is our memoization solution. It got accepted, and hope you like this video. Next we will try to see the next solution. So it is, we have seen the memoization solution. Next we will try to optimize we will try to eliminate this auxiliary stack space. How we can eliminate this auxiliary stack space? So we can use a tabulation method here. Tabulation solution. In tabulation, what we have to do here? We have to see what is our base case. Before that, we will try to change this. We can have a vector of okay. I have another idea. Before going for tabulation, we can try to reduce this m into n into k to m into n solution. We have used that three-dimensional array, right? You can see here, you can see one thing here. What is this kth index? Kth index is nothing but m plus n, right? The kth index, the size is nothing but m plus n. What will be my k? K is nothing but I plus j, right? So instead of taking another variable, another dimension of k, we can calculate this k as I plus j itself, right? We can do it. So we can we declare a variable int k which is I plus j. So we will use this k here. So and we have we are converting into a memoization solution by considering the changing parameters. So now we can see that there are two parameters only changed. So we can reduce this three parameters into two parameters, which is 2D array. So instead of going for a 3D array, we can go for a 2D array. So now we will try to run the code. Before that, this dp of ij, here dp of ij, and here also dp of ij, right? Yeah, we can eliminate this k plus 1 in our function call as well. Now we will try to run the code. Here also, sorry, why it is this slow? We will try to refresh it. One minute. Okay, now we will try to run the code. Hope the server is slow. Now we will try to submit the code. What we have done here is we have reduced this memoization solution. As you can see here, this is 100% accepted solution. So we have reduced this memoization solution of order of m into n alone. We have reduced this k. So we have eliminated this k. So we have converted this as 3D solution, 3D. This is a 2D problem. So we will convert it to a tabulation method now. What we have to do in tabulation is nothing but in reverse manner we have to store the results. from 0 we are from 0 we are going till m into n. Now we have to come in reverse order, so we have to come in reverse order, which is nothing but 0 to m, which is we are going from 0 to m and 0 to n. Then we have to come in reverse order, which is nothing but m to 0 and n to 0. So bottom up fashion we have to fill it. So bottom up fashion we have to fill it. So we will finally return dp of 0 comma 0. We will eliminate this. So now how we are going to convert this? There are two parameters, so we will write a two for loop. Int I equal to m minus 1 till I greater than or equal to 0, I minus minus, for int j equal to n minus 1. It is not n minus 1, m minus 1, it will be m n, right? M n, j greater than or equal to 0, j minus minus. And what are the base case? If my I is m, size of the string, and j is n, the size of the string, then what I can say is dp of ij to be true, right? Else if what I can say is these are the cases. These are the cases. This case I have filled I is m and j is n, then it is returned true. We have returned true. This we have filled it. Oh sorry, here we have to declare the two in I have changing this for only this for loop, that is the column size is nothing but the second for loop, the length of the second for loop. The length of the second for loop is n, it is not m. So it should work now. We can just run the code again. We'll use this use this wrong test case as well and try to run code. The column size is n, it is not m. I have made the mistake. But even though it shows the shows some error, let me analyze 1 minute. What if this all conditions fails? We have to have another condition, that is curve of j is false. Now we will try to run the code. It gets accepted. Now we will try to submit it. So we have also optimized this to a 1D array, space optimized. So time complexity here is order of just m, sorry, the size of the second array is n, and space complexity is just order of n. So we went through all the approaches: recursive approach, then memoization solution for 3D, then memoization for 2D, then tabulation, and then space optimized. We have went through all the approaches. I will put in my description as well. We have this time complexities, and hope you like this video. Until then, bye. Tomorrow, let us see in tomorrow's LeetCode daily challenge. We have discussed all the solutions.